What's up, guys? Welcome back to another video, and today we'll be talking about inverse derivatives. And you might be wondering, well, you haven't talked about the derivative of a sine function yet. Shut up. I wanted to do this because I thought about it on the bus, and I was just like, that makes so much sense now. So for y'all BC kids, I think this will make a little bit more sense to y'all. For y'all AB kids, please try to understand this because it will become important to you later. I think in Unit 3 or Unit 4 around there. So essentially, inverse derivatives, what are those? Well, you have your typical sine functions we'll be talking about today. So we'll be talking about sine, cosine, and tangent. Now, if you're a BC kid, calculus BC, you might remember that these different functions have their inverses. And now, if you're really good at AB, you will understand that the derivatives of each of these functions respectively. So for arcsine, it's just 1 over 1 minus x squared. For arc cosine, it's basically the same thing. I'm missing c there. Don't roast me. It's just basically the same, just negative 1 minus 1 minus x squared. And for tangent, it's basically the same thing too. This is assuming they all have x. So it's just equal to 1 plus x squared. But today on the bus, I was just thinking about the little right triangles. I was just thinking about arcsine, essentially. Arcsine of x specifically is equal to theta. I was just thinking about the relationship between that theta and then how you can get the different sides of the right triangle just through this way, because you'll get sine theta is equal to x. And if you remember closely, you can just go back to high school geometry. X is essentially just the opposite, and 1 is the hypotenuse, and that's where the ratio comes in. So you can say these sides are x on the opposite, 1 on the hypotenuse, and then 1 minus x squared here on the adjacent side. So then I was thinking to myself, this looks very, very similar to a derivative of arcsine of x. And so I got to thinking, I tried doing the theta ddx theta, but I didn't know how to. But then I switched it up to y. So here's what I did. I just switched it up to y because essentially theta is just like another way to say the angle. But if you say sine y is equal to x, you're essentially saying the same thing. Any mathematicians watching, don't quote me on that, please. But essentially from here, if you were to take the derivative of both sides, you would get cosine of y times dy dx, because you're taking the derivative with respect to x, and then you're taking the derivative of y. So you have to do dy dx is equal to 1, because x derivative is just 1. And then from here, for cosine of y, we can just look at our little triangle, and we can see that our adjacent side is 1 minus x squared. Then our hypotenuse side is just 1 times dy dx is equal to 1. And this is the cool thing. Watch. You can just divide both sides. Isn't that so cool? And watch, I'm going to prove our cosine. So watch this. Cosine of y is equal to x. You set up your little right triangle again. This time, this is adjacent over hypotenuse. So your hypotenuse is the same. Your adjacent goes to here, and this is the side. Now you take the derivative. And so derivative of cosine of y, if you remember closely, is negative sine of y times dy dx is equal to 1. Then from here, negative sine of y, or just sine of y in general, opposite over hypotenuse. So again, you would just do negative 1 minus x squared over 1 times dy dx equal to 1. Then divide everything by negative 1 minus x squared. So when you're given dy dx is equal to negative 1 over 1 minus x squared. And then for arctangent, this is the fun part because this is the one most people remember most, simply because it's like really simple. Because it's just 1 over 1 plus x squared. But you ever wonder why? Here's where we're going to find out. Arctangent y, is equal to y. So then tangent y is equal to x. From here, take the derivative of both sides. And then from here, tangent y, derivative is just secant square. Y is equal to 1. Now we have to go back to our little triangle, and we're given x, right? Tangent x. X, in this situation of tangent, is equal to opposite over adjacent. So this would be x, this would be 1. Then you add them up for the hypotenuse. It's root 1 plus x squared. And then from here, secant is really just saying it's just 1 over cosine, or just like flipped. So instead of saying it's adjacent over hypotenuse, it'll be hypotenuse over adjacent, which is equal to secant. So when the hypotenuse is 1 plus x squared, adjacent is 1, so we just write down 1 here. So then from here, we can say that secant squared y is equal to 1 plus x squared times dy dx. Don't forget that. I kind of forget that. Is equal to 1. And from here, you can actually just cancel roots. So then it's just 1 plus x squared times dy dx is equal to 1. And to leave dy dx by itself, you just divide by 1 plus x squared. And then dy dx is equal to 1 plus x squared. Therefore, the derivative of arctangent of x is equal to 1 over 1 plus x squared. Isn't that just so amazing? like, that's just so amazing. And you cannot tell me, like, oh my God, it just clicked for me on the bus right today. I was just thinking about it. I was doing coding, I was doing programming, I was doing Python, and I was just so bored because I just wanted to make this video. And oh my God, it just makes so much sense now to me, and hopefully to many, many calculus students out there. This is why I always advocate for derivation rather than memorization. Because if you memorize, sure, you can memorize the inverse, derivative tangents or whatever. But if you truly understand them, you're able to have moments like these that just like feel really, really good, and you know where the equations are coming from, and you aren't just reading from an AP like cheat sheet or whatever. That's just my opinion. Thank you for watching. I just really wanted to make this video because it made a lot of sense now. So thank you for watching. Please like, subscribe, share, do anything, if you want to support me. Thank you for watching. I'll see you on the next one, and goodbye.